We're going to do a review problem here from one-dimensional motion, and in the next video after this one, we're going to tie these answers into that video. We're going to launch a blender upward at 37 meters per second. We want to know how long it's in the air and how high it goes. We've talked many times that whenever you are dealing with projectile motion, you need to choose a convention in the up and down direction, which way is positive. And I'm going to choose upward to be positive. And what that means is Vy initial is going to be positive 37 meters per second. The acceleration in the y direction, the acceleration is due to gravity. Gravity pulls in the downward direction. So that's going to be negative 9.81 meters per second squared. Now, we have a couple of options to figure out how long this thing is going to be in the air. The option I'm going to choose is to calculate the time that it takes for the blender to get to the top, and then I'm going to double that because it's going to take the same amount of time to go back down. At the top, the velocity of the blender for an instant is going to be 0 meters per second. And what that means is that I can use these three quantities in order to calculate the time that it takes to get to the top using this equation right there. Here we go. Ay equals Vy final minus Vy initial divided by time. Vy final at the top is 0, so that means that the time to the top is equal to the opposite of Vy initial divided by Ay. The opposite of 37 divided by negative 9.81. And that comes out to be 3.77 seconds to the top. Now that is a useful number whenever we're going to calculate perhaps the maximum height. But that doesn't answer our first question, which is the time that it's in the air. So the time that it's in the air is going to be double this because it's going to take that same amount of time to come back down. So when we answer the first question, it's going to be 7.54 seconds. Let's now figure out how high this blender goes. And if we refer to our equations here, how high is definitely a dy. So any equation on the right side of this sheet that has dy in it is fair game. This top one, no good. It doesn't have dy in it. But the other three do. Really, any of those potentially could work. The problem, and it's not really a problem because sometimes you can't get around it, but because we can here, we're going to say that it's a problem. The problem with this second equation and finding dy and this bottom equation using dy is that they both depend on time. And we've calculated time here. So if we use the second equation or the fourth equation and we use one of these times and we've messed up the time, then we're going to mess up our dy calculation. Again, sometimes you can't get around that. You have to use an earlier answer to calculate something later. But here, we can get around that by using this no time equation. Vy final squared equals Vy initial squared plus 2 Ay dy. At the top, see this, maximum height. So the blender is at the top when we're interested in the dy. And at the top, Vy final is 0, which means if we solve this for dy, stop the video if you need to take some time on your own to convince yourself that that's what that would solve for in terms of dy. We're going to get the opposite of 37 squared divided by 2 divided by negative 9.81. This numerator is 37 squared, change the sign. So that numerator is a negative number. It's not negative 37 squared, which would be a positive number. It is a negative number. It cancels out this negative that's in the denominator, and that's going to give us, according to my calculations, a height of 69.8 meters. If you had used the second equation or the fourth equation with the time of 3.77 seconds, because that's how long it takes to get to the top, you would get the same answer. There's more than one way to get there. We're now going to move ahead to what about when you start launching projectiles at an angle. So here's our initial launch velocity. We're going to launch it, in this case, above horizontal. It's going to have a Vx component. It's going to have an initial Vy component. We say initial Vy because this component is going to constantly be changing because of the acceleration due to gravity. Vx is constant, and it's going to stay the same the whole time. So Vx is equal to Vi, if you look at the picture, times the cosine of theta, and that quantity is constant. And the reason it's constant is because the acceleration in the x direction is 0. Vy starts at, again, if you look at my triangle near the top of the screen, we use the sign whenever we're trying to find legs of triangles that are opposite our angles. So it starts out as this, but it changes at the rate of ay as time passes. So that Vy initial is only good for an instant. The Vx is good for the entire time that the thing is in the air.